The headline about Netflix using an AI-generated Gene Wilder voice suggests a solved problem of digital resurrection. The reality for the engineering team behind it is far more complex than just generating audio. It requires solving hard constraints around inference latency and cost per hour that do not exist in standard text-to-speech models. While users see a cool trick, the production pipeline has shifted from optimizing model accuracy to managing real-time compute costs on massive GPU clusters. The engineering challenge isn't making Gene Wilder talk. It is doing it fast enough, cheaply enough, and legally safely enough for a global streaming platform without breaking the bank or buffering the stream. This story reveals that the real engineering battle is no longer about training better models, but optimizing inference, reducing latency to prevent buffering, and managing GPU costs so they do not eat into margins for every hour of content streamed. When you hear news like this, it feels like a breakthrough in artificial intelligence capabilities. However, for software engineers and data practitioners, the question shifts immediately from what is possible in a demo to what is feasible at scale. The headline implies that we have cracked the code on voice synthesis. In reality, the team behind this content is fighting a war of infrastructure constraints rather than algorithmic innovation. They are not asking how accurate the model sounds. They are asking if the system can generate the audio under 200 milliseconds without stalling playback. This forces a move away from massive, slow models toward optimized inference pipelines that balance quality with compute cost per hour. The technical reality of real-time generative voice synthesis is fundamentally different from traditional dubbing. In standard production workflows, audio files are pre-generated and stored on servers. Viewers stream these static tracks without any computational delay during playback. Real-time generation changes the architecture entirely. Systems now need to intercept subtitle streams and trigger line-by-line generation via inference, APIs running in cloud-based containers or local Docker environments. This introduces new failure points that simply do not exist with pre-rendered audio, network jitter, GPU queue times, and a computational cost that scales linearly with content duration. If the pipeline slows down by even a fraction of a second, the illusion of reality breaks immediately for the viewer. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This shift in requirements exposes the massive hardware demands hidden behind consumer-facing features. High-fidelity generative video and audio synthesis requires significant resources that go far beyond what standard cloud instances provide. Netflix's own open-source research on their VOI model confirms this reliance on high-end GPU infrastructure for AI tasks, specifically requiring graphics processing units with 40 gigabytes of VRAM, such as the A100 class chips, to handle complex temporal consistency and interaction-aware rendering in near real-time workflows. When you scale this requirement from a single demo instance to millions of concurrent users streaming globally, the financial engineering problem becomes acute. The cost per hour for inference rises dramatically when every second of content requires dedicated high-performance compute resources rather than simple file serving. Developers often mistake model capability for product feasibility. Just because a research paper demonstrates that a model can clone Gene Wilder's voice in isolation does not mean it works at scale on Netflix. This story highlights how the engineering priority has shifted from asking how accurate the voice is to ensuring we can generate this line under 200 milliseconds without stalling playback. The infrastructure bill for these features is substantial, and the trade-off between latency and cost becomes a critical decision point for any team attempting similar deployments. If you cannot afford the GPU hours required per minute of content, the feature remains a prototype rather than a product. There is also a significant behavioral blind spot that engineers must account for when deploying generative AI in production environments. Research into generative AI behavior indicates that users often overtrust model outputs as infallible authorities. In studies involving participants interacting with these systems, more than 40% of people treated the AI predictions as absolute truth rather than probabilistic suggestions. This behavioral shift means engineers cannot just rely on good enough accuracy, they must build robust guardrails and latency monitoring because a single glitch breaks the illusion entirely for the user. When users treat the output as an infallible authority, any delay or artifact is perceived not as a technical limitation but as a failure of the technology itself. The move from static dubbing to dynamic synthetic talent requires rethinking audio pipelines entirely. Instead of pre-rendered tracks, systems now intercept subtitle streams and trigger line-by-line generation via inference APIs. This introduces new failure points including network jitter and GPU queue times that were previously non-existent in traditional streaming architectures. The computational cost scales linearly with content duration, meaning every additional minute of dialogue adds a direct financial burden to the platform's operating expenses. For practitioners, this highlights a critical career shift. Expertise in model architecture is now secondary to understanding system design trade-offs around compute efficiency and real-time pipeline reliability. In production, AI environments where users treat outputs as infallible authorities, engineers must build robust guardrails because any latency glitch breaks the illusion entirely for the viewer. The engineering focus has shifted from how accurate the voice sounds to whether we can generate this line under 200 milliseconds without stalling playback. This forces a move away from massive slow models toward optimized inference pipelines that balance quality with compute cost per hour. High-fidelity generative tasks require GPUs with at least 40 gigabytes of VRAM, like A100s, just for inference, turning every minute of content into a significant financial calculation rather than a simple file delivery task. The most valuable engineers in the AI era are not just those who can train a model or achieve high accuracy scores on benchmarks. They are the ones who understand how to make that technology run cheaply and instantly at scale while maintaining user trust. As generative capabilities become more accessible, the barrier to entry for successful products will no longer be algorithmic novelty, but rather system design mastery around latency, cost management, and reliability under load. This is where the real engineering depth lies, in making the impossible look seamless through rigorous infrastructure planning and intelligent trade-off analysis. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.